Hey everybody! Today we're going to be talking about proving triangle parts congruent to measure distance. This is 4-4 and it is problem 2. Congruence for measurement. Here's the picture. So it turns out that Thales, a Greek philosopher, he was said to have developed a method to measure this distance to a ship out at sea. Do you see the ship out at sea? He made a compass by nailing two sticks together. Standing on top of that tower there, he would hold one stick vertical and tilt the other until he could see the ship, it's marked with an S, along the line of the tilted stick. With this compass setting, he would find a landmark L, do you see the tree with an L under it, on the shore along the line of the tilted stick. How far would the ship be from the base of the tower marked R? So you're given that angle TRS right here, TRS, and angle TRL are right angles. You are also given that RTS, this angle up here, is congruent to RTS over here is congruent to RTL over here. So you can actually see it's really hard to, it's kind of tiny. It's a little red line there. It's also a little red line there. Those are marked congruent. Okay, your job is just to prove that RL is congruent to RS. He's trying to determine how far that boat is away from the tower. And he's going to do that by measuring this one. If he were to measure out here, he would have to swim. He would get wet. We don't want him to get wet. We have to try to keep him dry by measuring back here on land to see if it's possible to measure out to that boat. All right, let's see how we do this. Given TRS and TRL are right angles and angle RTS and RTL, they're congruent. We're going to prove RS is congruent to RL. Let's start out with the end. What am I proving? I'm proving that RS is congruent to RL. I'm also going to, in order to do that, I'm going to follow the same strategy that I used before, which is to prove that these two triangles are congruent, because if I can prove that these two triangles are congruent, then I know that all of their sides are congruent, and I know that all of their angles are congruent. I am noticing that if I have a right angle here, and I have a side here, and I have an angle up here, that I should be able to say that this is AS, my cursor went on ASA. So let's prove these triangles congruent with ASA. My first step is to write down that RTS is congruent to RTL. How do I know that? It's given in the words. It's also given in the arcs that are written on the top there. TR is congruent to TR. How do I know that? I know that because of the reflexive property of congruence. It does not say that TRS and TRL are congruent. It says that they are right angles. That's an important distinction. It says that they're right angles. That is a given. I have to still say that they're congruent in my proof. So I'm going to need another A down here. Now this A is actually referring to the same angle. So I'm going to need an extra line here, because I need the line that says that TRS is congruent to TRL. If they're both right angles, remember right angles means it's 90 degrees. And if if this guy is 90 degrees and this guy is 90 degrees, well, that is congruence, right? So now I can say that they are congruent, And the reason I can say that is because right angles are always congruent to each other. So now I have all of the components to prove that triangle STR is congruent to triangle RTL using ASA. So I should be able to easily get down to what I'm proving, that RS is congruent to RL. How can I do that? Because of the corresponding parts of congruent triangles are congruent. So if this guy was 100 feet, if you were to take out a tape measure and measure this guy to be 100 feet, well, then he should be able to say that this over here corresponds to that. So then the distance between the tower and the ship out at sea is also 100 feet, right? True beans. All right, let's try another one. Congruence for measurement. Ooh, this one's a little bit blurry, but hang with me here. It says that you have been given that AB is congruent to AC. We've also been given that for this line right here, BC, that M is the midpoint. We're supposed to prove that angle AMC, let's see, AMC, so this one here that looks kind of like a right angle but does not have a right angle marking there, which means it's probably really not quite a right angle, is congruent to AMB is congruent to AMC. So this one is congruent to this one. And if we're going to prove that those are congruent, then they would have to be, wouldn't they? Well, all right, let's go ahead and do it. Angle AMB congruent to AMC. That is what we're proving. Let's try and get these guys congruent so we can say that all of the corresponding parts, all the corresponding sides, and all of the corresponding angles are congruent between the triangles. I'm going to go ahead and just put down that law because that's what we're going to use to do it. Well, there we go. Both of those triangles congruent. I think that we can prove it using SSS in this case. So if we know that this side is congruent to that side, we know that this is a midpoint, then that means that this must be congruent to that. And of course, with the reflex, I should be able to say that this side is congruent to itself. So I think I know all the sides. So let's go over each one. AB congruent to AC, that is given in the picture. It is also given in the words. MA congruent to itself, that is the reflexive property of congruence. Then BM is congruent to MC. I know that because midpoints create congruent segments. All right, everybody, that's it for today. Get after it. You got some work to do on this.